Welcome back to the podcast devoted to JavaScript. This is HashBang. HashBang features interviews and discussions about the latest in JavaScript and the JavaScript ecosystem. Brought to you by OK Grow, a JavaScript consulting and training company.
Welcome to HashBang. I'm Robert Dickert, and I'm a software engineer at OK Grow. With me is my host, Paul Dowman.
Hi.
Today we have a special show. Our guests are all speakers at the Assert JS conference, the first conference dedicated entirely to testing in JavaScript. The conference will be held in San Antonio on February 22nd, and my hope is that this will be the first of some great discussions that will happen at that event. I'll just mention that we'll have a discount code at the end of the show. But now let's begin the discussion. Our guests today are Kent C. Dodds from PayPal, Justin Searls from TestDouble, and Gleb Bahmutov and Brian Mann from Cypress. Welcome, everyone. Can I just get each of you to do a quick self-introduction?
Sure, I'll go first since you mentioned my name first. So my name is Kent C. Dodds, and I work at PayPal. I am an instructor on Egghead, IO, and Front-End Masters. I'm a GDE. I work on I represent PayPal on the TC39 to standardize JavaScript. And I'm a husband and father. That's about me.
And hi, my name is Justin Searles. I'm a co-founder at TestDouble. We're a distributed software consultancy of about 40 consultants that are just all trying to help teams better succeed with software. I've been trying to help teams and help myself get better about testing JavaScript for going on like 9 years now. So I've been around the bend a few different times, and I'm really excited to see this conference happen and see this kind of discussion broaden.
Great. Gleb?
I'm Gleb Bahmutov. I work at Cypress. With Brian, I have a pleasure of arguing with him about testing every day.
Thanks, Gleb. I'm Brian Mann. I'm the founder of Cypress. Over my career, I've probably written at least 10,000 tests, so I'm really passionate about bringing innovation into and making the experience better, writing and testing modern web applications.
Great. Thanks, everyone.
And I'm Paul Dowman. I'm the founder of OK Grow, which is also a software consultancy, and we focus on JavaScript. And I've been a developer since the early days of JUnit. So that's my that's where I came from. And then through the Ruby community, which is also very test oriented, and in recent years it's been JavaScript. Thanks.
Great. So my goal for today is to have a discussion about testing, how it's different in JavaScript, and how we can use today's tools to make better software. I know that some of our listeners may need a little more background in order to follow the discussion. So can one of you guys give us a quick summary of the major types of testing and when you might use each?
Yeah, I can do that. I actually gave a lightning talk, or what's Ignite talk at FluentConf a couple of years ago, called "What We Can Learn About Testing from the Wheel," and it's kind of a fun talk. But the idea is that there are like infinite different forms of testing. So you've got penetration testing and regression testing and user acceptance testing. There are tons and tons of different forms of testing. And the idea is like they all have their benefits and trade-offs that you should be aware of and probably apply in your applications. But I think what we're normally talking about, or what most people are talking about when we're doing automated like application testing, is unit testing, integration testing, and end-to-end testing. And so I think those are probably the three most commonly used forms of testing. And so, yeah, the distinction is that unit testing is testing a very small piece of functionality in isolation from the rest of the environment. So like the simplest form being that of a function, like you have an add function, you give it some input, you expect it to give you some output, and it doesn't really care about the rest of the application. And then all the way on the other end of the spectrum is end-to-end testing, where you pull up the full application, you are interacting with the application the same way the user would. And then integration testing is kind of between those two, where it takes several units or even services and ensures that they're communicating properly. Yeah, so I think those are the three main distinctions. I'm sure people have other things that they want to add to that.
Do we want to talk about mocks and stubs and how they relate to, like, which kind of testing they relate to? And I think some people are maybe confused about that. Do you want to take that, Justin?
Yeah, well, just on talking about types of testing, you know, I could probably go 45 minutes, and that probably would be unfair to, you know, the other smart people that we have here, and also not get a lot done. I'll say a little bit about mocks, spies, proxies, fakes, test doubles, whatever you've heard them called before, however you've used them. They were first introduced in like the late 90s, 99, 2000. The London Extreme Programming Group, people like Steve Freeman and Nat Price, introduced them as a mechanism for actually like exploring legacy code. They'd kind of like imagine like a big legacy code base as like being the Death Star, and you'd pass in kind of like a tripwire, what they called a mock object, that would kind of go into the Death Star, and then like, and whenever it was interacted with in any way, it would explode, and it would be a way of informing them and helping them understand how that thing, how that argument was getting interacted with by the unknown confusing subject under test. That their usage of test doubles, which is like the superset broadest term, that's why I use the term test double when I'm discussing this stuff, because it gets so hazy so quickly, and having to peel back the layer of the onion yet one more step. Test double was coined by Gerard Mazaros in XUnit patterns to evoke the image of a stunt double, like a thing, a fake thing that stands in for a real thing, but inside the purpose of your test. Right, so the London Extreme Programming guys, they continued working on using test doubles as a way to get design feedback when you were unit test driving, using test-driven development with unit tests of a new system. So you'd work outside in, you would start a test of a thing that didn't exist yet, and then you would ask, what other things don't exist yet that could exist to help me like break up this workload? You'd use fake objects to kind of wire everything together, and they were programming Java, so they'd also get like, you know, type signatures and create all the value objects and stuff and the signatures that would pass between them. And then you use the test as the sounding board, so that when that test of that thing, using all these fake things underneath it, once that test was done, then you could feel pretty confident that like your design would work if you would just implement these now smaller and simpler things. And it was a way to arrive at repeatable, simple designs of small objects, which is like the, you know, hard problem, I think, of design generally, and of like classical test-driven development, like specifically. So that's what they are and why they exist. But in their practical application, how actually everyone always uses mock object libraries, regardless of what language you're in, it's 99.9999% of the time that I see people use test doubles and mock objects is, this test is painful to write, or this test is slow, or I can't fake this thing out, or I feel like I should, or I'm told that like I have this tool here and I should use it at some point. And it's just used as a cudgel to like arbitrarily knock stuff out when trying to get, you know, some amount of certainty that a thing is working, when all they're really doing is like undercutting the veracity of the test and mutzing with reality. And so if you've seen test doubles and mock objects and you're not familiar with the book Growing Object-Oriented Software Guided by Tests, then boy, do I have a lot to share with you. So that would be my little stump speech on mock objects.
Yeah, so I guess if I were to weigh in on stubs and my own personal usage of them, I would just try to simplify it, right? I would say the first general rule of thumb is don't stub the thing that you're testing, right? So if you have an object, you wouldn't stub its own methods. And if you needed to, then that's a perfect opportunity to abstract that away into a different object. So really, I just use it to test the collaboration of objects, or to create edge cases that I want to account for. You know, it's very difficult to, if you're talking about Node and you're talking about reading and writing files from the operating system, there's a host of things that could go wrong, and it's often, you know, way more difficult to actually create those situations. So you might stub a method to throw or to reject, and then you can test how your code reacts to it. If you're using dependency injection, those objects that are being injected, or that the object under test is interacting with, you would potentially use stubs to interact with all of those if you wanted to force the collaboration down something. I think that stubs are useful outside of just unit tests. So even in integration end-to-end tests, you often want to stub out network responses so that you can basically isolate, carve out the back end, and but still get true responses, if you will, like the actual data layer of that, so you can see how your application responds to that.
Go ahead, Kent.
Yeah, so I think that like the core piece of the idea of test doubles, or the trade-offs here, is when you use a test double or a mock stub, whatever. I'm just going to call it test double. Thanks, Justin. That's good. So when you use a test double, you're trading off a some confidence for some making the some benefit for the test. So making it easier to test, or you know, or even possible to test. So for example, you have an application that has a checkout button. You're going to charge a credit card. So it's not, it wouldn't be reasonable to test that like the credit card is actually charged, and you're going to like make an assertion that the credit card company has charged your credit card. That would not be a reasonable test. And so you're going to make that test possible, like make the trade-off by adding the test double. And now you've actually removed your confidence that the credit card is actually charged. It's at this point, you're not making any assertions that the credit card's actually charged. So you're removing your confidence in that, but what you're trading that for is the ability to test it in the first place. And so with any time that you're using one of these test doubles, you are trading off some bit of confidence for, you know, some desired benefit, making the test easier or even possible.
So what do you think about?
I have nuanced things that I need to disagree with Kent about. Test double itself is like by design a really, really general term, and everything that Kent said is absolutely correct. There is a nuanced distinction though between the nature of that trade-off. Like for example, when Kent says you might use a test double to replace an actual credit card payment processor, there are several, like, from an implementation perspective, ways that you might do that, right? Like you might use sign-on or test double JS to, you know, poke a hole in a particular JavaScript method that was handed to you by that library, and accomplish that. Or you might set up like a fake server or a fake HTTP response or something like that might be like a coarser granularity, but would not couple the test to the implementation details of whatever like library you happen to be using. And that's all completely valid. That is like one category of ways that people use test doubles. But when I'm on my stump speech, when I'm pushing for people to use it for like the purposes of like test-driven design, it is not an active trade-off of confidence of working for ability to test. The trade-off is tests of delegators, tests of things that call other things. I look to those for like nearly zero confidence that anything is working. Like they are my canvas, and my paint is the test doubles that I'm using to try to wire everything together so that I have confidence that like if A calls B, calls C, calls D, then everything will be working. And my outcome from the test is actually like just design feedback to know that like now my job is to go make A, B, and C, and D. And hopefully those can be pure functions and I don't have to like, you know, recurse another degree, breaking things down further, which is just like a phenomenally different workflow than, like I said earlier, most people using test doubles just to poke a hole in reality so that testing becomes either viable or feasible or easier or whatever the case. And so Kent is speaking absolutely to most people's actual experience. but I had to dissent anyway.
Sure. Well, I guess, go ahead, Gleb.
I just want to point out, this was poetic, Justin. Like painting a canvas with test doubles, that's some poetic stuff about testing. Love it.
Yeah, I guess I wanted to try to sort of separate out and tease out like what probably most of our viewers are familiar with is that, you're either probably writing Node.js code, and of that, you're probably, you might be writing a library with a small set of functionality that you're going to publish on NPM, and your testing concerns are probably very different than if you're just trying to build, an API that's primarily communicating between microservices, for instance. And then on the other hand, we have the application developers that are primarily working in the browser. And I mean, stubbing is useful on all of those levels, but just to kind of like bring it back to what people are doing day to day is likely going to fall in one of those three buckets if you're writing JavaScript.
So go ahead, Ken.
So Justin, what you say makes me really interested, and I want to learn more about that, but I don't expect that we have time. There's lots of other things we want to talk about. So do you have any resources for anybody who wants to learn? I mean, I guess you mentioned that book. Is there anything else like, I'm mostly looking for code examples where I can learn about what you're talking about?
Sure. Yeah, I don't have a ton of great examples. Well, I've got example code, like my own open source repos generally follow what I call discovery testing approach. But I haven't written enough in JavaScript with JavaScript as the examples, and that's something I plan to do over the holidays, and as well as for my Assert JS talk. However, I've got this wiki that's just a random GitHub wiki I threw up that like tries to define a lot of these terms and explain stuff. It's just under testdouble/contributing-tests, and it's a GitHub wiki on there. And I just threw up a lot of thoughts there. And from there is a font of examples. Like I've got a 4-hour screencast series that I did showing how to do the game of life with outside-in discovery testing. But that happens to be in Java, which for the purpose of understanding like the point that I'm trying to make is maybe just as good an example. But yeah, I appreciate it. And Kent, we should pair up sometime, and I'd love to show you how I work.
That's great. Let's change topics just a little bit. One other thing I want to cover just in the general testing sphere is what is generally called the testing pyramid, or like the balance of how many of what kind of tests you should have. And I think you all may have slightly different approaches to this. Brian, do you want to start, since we haven't heard as much from you yet?
Sure. Well, I agree with Ken. Or I know maybe Gleb. I think Gleb is probably talk the least.
Gleb, do you have a comment on the testing pyramid? How do you decide where to put your tests, where to start, and the balance of how many you do of which kind of test?
Absolutely. So for our listeners, there is a concept of testing pyramid, right? Where at the bottom you have a lot of unit tests. And in the middle, you have integration tests, and you write few of them, so it goes narrower. And at the very top, you have just a few end-to-end tests that test the complete system. Could be a server, could be a web application. And the shape of a pyramid is kind of, wide base, right? We write a lot of unit tests because our tools right now allow us to write those tests very easily and run them quickly. And we have just a few end-to-end tests because, well, it's hard to actually run and write end-to-end tests. Imagine you have to test with deployed website, right? Well, you have to fire up Selenium, and each test takes a couple seconds. So obviously you would run a unit test a lot more, and you would write a lot more. So the shape of a pyramid is not really determined by our needs. The shape of a pyramid is determined by the tools we have right now, today. If it were up to me, I would write just end-to-end tests because that's the end users what they see, right? Nobody cares if you're, let's say, to use your example, PayPal mocked credit card works, right? What we care is that when you go to PayPal and try to pay, but PayPal.com works. That's what users care. But unfortunately, due to the tools we have, and it's really, really small number of end-to-end tests to write. We're trying to change that, but that's a different story.
Yeah, I think that's actually that reminded me of the comment earlier from Kent about trading off some of your confidence for convenience in some way. And I think another point with end-to-end tests is that they are often more brittle. So, and this may again be, I'm actually really curious what the Cypress guys have to say on this about, how much of this is a factor of the tools that we're using, which is specifically Selenium for most people. And Cypress is obviously an alternative to that, which maybe suffers from some of the same brittleness less. So I'm curious if you guys have a comment on that.
Yeah, absolutely. I mean, overall, I would agree with the assessment of the pyramid and sort of the boundaries between these and the importance, right? So I would say that Cypress actually enables you to sort of do like a new type of testing that's somewhere between end-to-end and integration, and then also somewhere between integration and unit, almost as if there's like 5 tiers. And if you think about it as 5 tiers, what we actually recommend are sort of the middle 3 when it comes to browsers, right? So let me just preface and just say this is strictly about web applications. It has nothing to do with Node, nothing to do with back-end services, like if you were writing those, right? This is purely for the front end. And I mean, overall, we agree, like true end-to-end tests that are going to involve every single service, that where nothing is going to be stubbed, nothing is going to be mocked, nothing is going to be controlled, right? So this true end-to-end test has got to really go out to PayPal or your payment processor or whatever it is and really do all those things. We actually don't recommend those. I mean, I would say that, you might want to have those for the strict, like happy path of just a few features. But overall, the idea is that you want to try to control your environment. You want to try to separate your application code and draw boundaries around it from all the external services that may interact with it. So in Kent's example, I would have, what I would describe as an integration test where I actually, spin up a browser, I load the application, and, I poke at the application either by using user actions or just, modifying a Redux store, just putting the application in the state that I expect it to be in. And then when I click the submit button, I would basically just ensure that the right structure of data was sent over the wire, or maybe that some function from a third-party library that has its documented API was called, and then that's it. And then I would just force the response to come back in. And then I would, independently probably test the integration of that button and the request, in some other manner, right? Like, for instance, if you were handling the request yourself and like proxying it instead of directly posting to PayPal, that would probably just be a unit test that you would write on your backend code. So in other words, I guess if I were to try to summarize this, I mean, we agree with the testing pyramid, but what we're trying to enable users to do is to have a better, more fine-grained control of their application so that it feels like an end-to-end test and you're getting all the confidence and coverage that all the components and everything work together, but that you can create themes in your application and tap into these themes in order to control the environment much better, to stub out the server, or like I said, to just modify a Redux store to just generate the state. Like, it's not worth visiting a link and clicking around buttons and filling out a form. Like, maybe do that one time, but then subsequently, if you need that state to go further into a test, like don't repeat the same actions. Just give your application the state it needs. Like, call application functions directly from your test code. And in that way, it's sort of acting like, more towards a unit test, but it's just involving and giving you greater amounts of coverage.
So Kent, you wrote a pretty popular post called Write Tests, Not Too Many, Mostly Integration. It seems to apply to this. Do you think your view of the testing pyramid differs from most people's?
Yeah. Sorry, just bad cough. Yeah, so I believe in the idea of the testing pyramid. Just as Gleb mentioned, it's like as you go up the testing pyramid, the tests get more expensive and harder to maintain and write and things. And Cypress is making, is kind of changing the game there in really nice ways. And so, yeah, I can appreciate that value. But one thing that the testing pyramid doesn't show you is that the confidence coefficient goes up as you go up the testing pyramid. And so as you're writing your unit tests, like, sure, you know that this add function is always going to add these numbers together, right? That's fine. But you don't know that your other code is calling that add function with the right numbers or whatever. And so just like Brian mentioned, I believe that, yes, you could just like call or like set up the state of your Redux store or whatever, like, but you should definitely make sure that your Redux store can get into that state from the application.
Right.
I think that's really key. And so, yeah, all of this is really a balance, and you are making trade-offs with every decision that you make. And when you make a trade-off, see if there's a way that you can cover the downsides of that trade-off in another test or something, because really all of this testing stuff, it's all about confidence. And so I don't really care what method of testing you're using, so long as you're making the best trade-offs for your use cases. Yeah, so I actually had one person who didn't like that blog post say that what I was suggesting was the testing ice cream cone rather than the testing pyramid. And I actually kind of like that imagery because I like ice cream. So yeah, I'm in favor of integration tests because I feel like they make strike a good balance between the convenience of unit tests and the confidence of end-to-end tests. They don't give you 100% of both, but with the right tools, you can have most of confidence and most of your convenience. And so, yeah, I'm definitely more in the integration camp.
There's two different. Sorry, go ahead. Yeah.
Well, I was going to say I couldn't agree more with Kent, but to kind of like bring it back to real world examples, I would say if you're distributing a library or a very specific component with a very specific surface area and API, you would likely have just unit tests, right? Because then you can achieve 100% coverage, and there you go, right? So in the node world, it's primarily going to be that. And if you are, a component library author on the front end for Vue or for React or for Angular, it's probably also mostly going to be unit tests because you can get 100% coverage. But it's like what Kent is mostly describing is what like real world day-to-day application developers, where they're grouping a ton of components, including their own. They're not, this one thing that does one specific thing. And integration is what basically ensures that the whole system works together correctly.
I have a quick comment that just might frame this as well. People have different reasons for writing tests as well. So, I think what we're talking about right now is sort of focused on ensuring that there are not going to be regressions, bugs that come back up in code that previously worked. But there is another reason for writing tests, which is as a way to actually design your code and a way to get your code written with actually less pain. In my experience, the times where writing tests feels good are the times where it's saving you from something. So I'm sure everybody knows that feeling where you're working on something and you have to click through, get that form up on the screen again, submit the values. Oh, did it work? What did the log, whatever I logged out, does it look right? So writing tests can also save you from that. And that's the feeling where they feel good, but they can also help you design your code in more modular ways as well. So, I think depending on what your primary goal is for testing, that those different types you might look at those different tests differently.
Yeah, I've got some dissenting opinions from what most people are sharing, although I think I think they're of a piece with where Paul's going. I've always disliked the testing pyramid as an example because in practice, I've spent, as a lifelong consultant, I've visited dozens of teams and spent thousands and thousands of hours testing. And so when I look back and think about like tests that were actually valuable versus tests that were just like a chore that had to be done and were slowing the rate of change without a lot of effective help given. When I look back on all that, end-to-end tests can be useful if they're designed in a way that they kind of like walk an imagined stakeholder through all of the system, rather than like, a whole bunch of cucumber features that just create, read, update, destroy a thing, shut it down, start it up again, but rather like walk through the whole system, tell me that the lights are on, tell me everything's glued together right. That's usually what I look for there, because like anything deeper, Selenium and related like automation tools just aren't necessarily able to tell you a whole lot about like things looking right. And there's tools like Sentry and whatnot that try to make things look right. But like, as to Kent's point, as you go up the chain, it's true that like the maintenance cost goes up. I think the nature of that maintenance cost going up is in many ways that you are calcifying a lot of the assumptions about like how things have to be exactly as they are right now. And that is only useful if things aren't going to change. And so then things change, because that's what we as software developers get paid to do, is change things. And then we basically have to run through the whole process of like, fixing a test that doesn't really understand what's being tested. I want to flip one thing that Kent said, though, which is that I think he phrased it as the confidence coefficient increases as you go up the chain. And that hasn't exactly been my experience either. It does, it's very easy to make pithy arguments that like everything's individually unit tested, but like, look, it doesn't actually work when it's plugged in together. And come up with like kind of colorful metaphors and funny GIFs and stuff. And I get it, like that is absolutely theoretically possible. In fact, it is intuitively what you would think would be the case. But I just shared an article that Michael Feathers posted years ago, where he was like very skeptical of this outside-in mock object-driven approach. And he was also very skeptical of clean room design, which would like basically design all of the things on pen and paper first and then implement them. Because he was like, this is super wasteful. This isn't travel light at all. Like test-driven development, like bottom up is going to be way more effective than this. But there's a phenomenally weird sensation when I'm doing like outside-in testing and like maybe 2/3 of my objects are just like mocked to hell and back, and everything is super duper little, and every single test only tests the like lexical, like symmetrical paired, unit on the other side, and like nothing has ever been called in production. No method has actually like gone down an actual function stack and invoked. But then I like fill out the whole tree of all the little objects, and then I actually go and use it. And I'm still to this day blown away that like 9 times out of 10, everything just works. Like when you turn the lights on, like the integrated whole is just like magically together. And Michael's, I think, theory in that post is that like what we're really doing when we're writing programming is like we are encoding thoughtfulness, and tools and workflows that maximize intense thoughtfulness tend to embed and encode our desires of what the system should do effectively. And that is one reason why I rail on snapshot testing and why I tend to not encourage people to overinvest in automation tools, especially required playback tools, because they're actually like, if anything, they select for thoughtlessness and encourage people down that road. So that is my soapbox pitch on test pyramid, and I'll get off my rocker.
So, I mean, in theory, Justin, I also agree with you, but could you give an example? I remember reading your blog post from years ago about like the surprise, like there's this amazement that, hey, you've done it all correctly and it worked the very first time. And I agree, like there have been opportunities where that has absolutely happened for me, but exclusively in node code. Never, ever, 0 times in a browser has that ever like worked or applied, because generally when you're building a feature in the browser, it's all about like, using, your senses, your eyeballs, the experience for the user, as opposed to black and white code.
Brian, that is an excellent point, and something that I think needs to be mentioned every time JavaScript thought lords talk to an audience. And that is that by and large, most people that are visible in the JavaScript community who speak and talk and stuff spend more of their time writing libraries and framework code than they do writing web application code. And so a lot of the advice that you hear about what makes for good JavaScript modules or components are being kind of peddled by people who mostly don't have the same concerns that a team building like a really, really broad and deep and big front-end web application should have, right? And so I would encourage everyone listening to take with a big grain of salt anything you hear about testing or about design or about what the right size of modules is or what a good deployment strategy is, if the author like mostly works in libraries. And these days, that's actually describes me. So you're right, that is a blind spot, Brian. What I would point people to is like some of the debates that happened in the acceptance test-driven community as Selenium was being invented, because what a lot of them suggested was, we are never going to perfectly automate what our eyeballs do. And it's really, really painful and it's really, really error prone to even attempt to do so. And so instead, what a lot of them suggested was to create a seam by which we could test just beneath the UI layer. Tools like FitNess were designed to enable this. And then by operating at just that layer where we're invoking, I don't know, like you could say like at a router layer or something like that, or a controller layer, and invoking just there on down. That way you could still have, 95% of the pyramid's height, but without the incredible diminishing return pain of that top 5%. So I completely hear you, completely agree. And that's, I think, the prescription most people would share.
That's really interesting. I think this might be maybe a good time just talk about JavaScript tools or in fact, what's even different about JavaScript testing. Like, for example, JavaScript has a lot of async code. So what's different about testing JavaScript than any other platforms or libraries, languages?
Well, I won't be too much help here because I pretty much spend most of my time in JavaScript. Like 99% of my time is JavaScript.
How about the community? I mean, I have a comment that the testing seems to be a little bit less in the community DNA in JavaScript than in some communities, like specifically Ruby is really good for that. So, for example, yeah.
I've only been in the community for a couple of years, and even in just the short time I've been in the community, I've seen a steady increase in the interest of testing JavaScript. So that's just my perspective. I think people are getting more and more interested in it, which is great.
Yeah, I think that's true. And a lot of, 5 years ago, Node was kind of in its infancy, and almost anybody doing JavaScript testing was heavily focused on UI. In fact, even that at that time, most people weren't building full applications with JavaScript, and it was like jQuery in your web page. So, I think that's kind of where we've come from. I agree that there's a lot more interest in it now, and hoping to continue to increase that. That's why we're putting on the conference. I'm excited about it. Well, so maybe I'll rephrase the question a little bit in terms of like, maybe just focus on the async. So how do we want to talk about how to handle asynchronous tests or testing asynchronous code, things that have anything async in them? Anyone have comments on that?
I mean, it is a huge problem for beginners. We see people get tripped up on it every single day. And I mean, I'm not really sure there is a solution other than just truly understanding what is happening, understanding the way that promises work, or, I don't know. I don't really have a good solution. We designed our APIs with all of this in mind. I feel like they're fairly elegant in handling this, but it sort of trips up, more experienced programmers at the same time with the way that it works, kind of making async code look synchronous to where your mental model is pretty straightforward. But even then it's incredibly difficult. I mean, it's just built into the way that it works, and we have to accept it and deal with it.
I think that there is a sickness in the JavaScript community that has unfortunately turned async versus sync into some kind of moral judgment, in part because it was the leading reason for Node.js's existence, but also because in an event-based user interface runtime like a browser, a lot of stuff has to happen asynchronously on an event loop. But there's so that's the basis, but like the trend of the JavaScript community to like increasingly approach these like very, very informationally dense and clustered little bits of behavior where a function might simultaneously route an HTTP request, go make several others, aggregate all of those asynchronously, do some sort of processing, and then like do all of that in anonymous callback functions. There's just so much like behavioral density in there that we kind of like get lost in understanding like what does async imply? And what async implies is input output. It implies like a network request or a file getting loaded or something like that. Or something, some bit of work getting like dispatched. And what I learned about design in all my other like languages prior to spending a lot of time in JavaScript was, well, I/O should live at the periphery of your application, but like the big meat and bones and chunky middle part, if you're building a big application, is going to be like logic, is going to be like business rules and functions that calculate things and do things the way that like, we need them to do. And to segregate the two is really, really beneficial because then you get all sorts of design benefits and flexibility from that. But the JavaScript world, the zeitgeist seems to just be on a collision course with like the maximally like tied up and gooed up combination of async flow control of IO heavy stuff tangled up with business logic, I think has like rotted our brains to think that async is a moral good and everything must be async. Whereas what I look for when I'm like writing unit tests is like as many like core pure functions, synchronous functions as possible, tested by boring synchronous tests. And async implies integration. And so I'm probably not going to unit test that at all. And I'll probably just have an end-to-end test go through all that. So that's my feeling on async.
I feel like the tools that we have now are like way better than the tools we had even just 3 years ago for testing async code in JavaScript. Like I remember when I was just getting started into testing and like getting into the callback stuff and just like the testing frameworks did not handle things very well, but the proliferation of promises, just promises alone have really improved the testing side of JavaScript, asynchronous JavaScript. And then like you add an async await and now testing asynchronous code becomes a lot easier. And then with on the React side where like, the user interface is asynchronous, you need to like fire off events and stuff. And so we have really super tools for React, and I'm sure Angular and Ember and Vue also have really super testing tools to make like dispatching or simulating these events really easy. And so I think that maybe part of the reason why the async code and the synchronous code are kind of mixed in some scenarios is because it's the testing or like it's just kind of easy to do things that way. Like I agree with Justin though. I should clarify. I agree with Justin that we should be taking the IO, the asynchronous stuff, and separating it out. But there is a point where it is a user interface. You can't really separate your click handlers from your UI code like that. You can't really do that. And so there definitely is a need for the testing tools to handle that gracefully. And I think that we're in a really good place today, and we're getting in a better place the longer we go, especially with async await. It's just like phenomenal. And the testing tools for simulating events is just really making testing better.
Agree. I mean, it just keeps coming back to the same sort of concept. Node code is just, fundamentally different than the way that we work inside the browser. And for our users, 2 tips. Number 1, Bluebird.js, and number 2, async await.
So on that, sorry, go ahead.
So sorry, it looked like Gleb had a comment you wanted to make.
I just want to disagree with you guys about the testing culture. So I come from C++ world, right? Where the only choice, let's say 10 years ago, was this weird CPP unit header template library that was rewriting your code so you could unit test it. And then I moved to C# and Java, and those had the frameworks, XUnit and JUnit, but it's nothing compared how good JavaScript is. right? Even when I just moved into JavaScript world, I first saw Istanbul. It would instrument your code so you collect data coverage. There is no way you can do the same thing in user space in C++, right? Like, or you have to jump through so many loops. But in JavaScript, you can write your own test framework. You can write all sorts of preprocessors, right? That will give you more insight into your code. And now we have an explosion of good testing tools like Jest, Ava, Mocha is on a run again. We have incredible variety of good tools for testing in both browser and Node. I don't think the async part is as complex now as we might think. I think the next step where the tools have to catch up is reactive code, where instead of testing a single asynchronous action, you have to test the whole sequence of asynchronous events. That's the next challenge. But right now, I think we're in a golden age of testing in JavaScript.
Yeah, I think that's great. One thing though is that there are a lot of options. So I don't know, is it worth taking a minute? I mean, we're getting close to time, but maybe is it worth taking a minute, sort of just talking about what are the main options and what you might recommend for various different things? And I think we've already alluded to like, if you're writing library code, maybe your needs are different than somebody writing application. So yeah, go ahead, Kent.
Yeah, so I have two suggestions for you. I write applications and libraries for both Node and the browser, and there are only two testing tools that you need, and they are Jest and Cypress, and they're just so good. So like I use Jest for all of my Node code, all my Node libraries, all my browser libraries, all my CLI tools. And then I prefer Cypress for the like end-to-end piece and the integration piece for browser testing. These tools are really, really good, and they're only getting better. So there are other options, and I've used them all, and they're great. But I just can't suggest or recommend or Cypress enough.
Cool.
What?
I can't disagree with Kent there. So
one thing that I see a lot among JavaScript developers is that the tremendous number of tools available to them. I mean, I've written my own test runner that I use called Teeny Test because I'm ridiculous. I'm not here to advocate that people use that because I'm not sure it's a good idea. But what I would say is like they're having so many tools when we're experiencing pain testing something. I think it leads a lot of people to think, well, I must be using the wrong tool instead of like I'm approaching this the wrong way. Same goes for like talking about like async as if or new language features or like reactive programming as if like testing tools necessarily ought to, and we should therefore consume tools that like respond to changing motifs and abilities of like production code. Like in fact, if most of your application is just plain old functions and you test them as mostly plain old functions, if you do have those plain old functions wired together through like a bunch of like reactive stuff or event loop callbacks or however it actually is in practice, like a good test doesn't necessarily have to be aware of any of that because it should probably be decoupled from that layer anyway and could just be one notch more integrated. Because at the end of the day, no matter how async and haywire and discombobulated like all of the actual code is for the purpose of like being, loosely coupled, like our apps are observable as humans would observe them, like as more discrete black boxes. And so sometimes, when we have like a new fancy way to write programming, our immediate impulse is, how do I write a tool that can like test this in a way that like makes me really, really engage with it? And I feel like that's just the wrong impulse.
yeah, so I know we're almost out of time, but I did kind of want to rant a little bit about end-to-end integration, like testing philosophy, something that I think all of, at least the users of ours constantly struggle with, or they want opinions and someone to kind of champion a process. So if there's time, I was going to kind of give some real world examples of how you might use a tool like Cypress, or I guess even Selenium for that matter, or how you might approach like day-to-day development. Is that cool?
Let's hear it.
Okay, so the first thing that every single application developer has to deal with when they're writing an end-to-end test, or an integration test, whatever, something involving the browser, is they need to log in. So Like what we would recommend is this is a critical path, right? So you need to write full-blown, true end-to-end tests around things like, an incorrect password, an incorrect username, basically everything that's a failure state, right? And then, okay, well, you've done that, and now you need to actually log in. Well, so in order to log in, you need this other thing, right? You need a user. So how do you get that user? What we've seen in sort of the failure of end-to-end testing is when there is a prerequisite, you then use the UI to generate the state for another prerequisite. And that's basically where it all goes wrong. So like, many of our users we've seen, okay, I need a user, so then let me go visit the area of the application that signs up a user. Let me fill out all those forms. Oh, now I have my user. Now let me go back to the login. Now let me log in. Now I'm through the system, and now I want to test the first thing inside of it. So now every single one of my tests repeats the same action, right? Creates a user, logs in a user, tests that one thing. And I mean, it's just like ludicrous, like back to like Kent's example with the shopping cart. If you're testing the shopping cart functionality, do you use your UI to log into the admin area to generate like 100 products to then add those products to the shopping cart just to do that? No, absolutely not. So what we recommend is this. You have a few like unmocked, unstubbed integration tests to test like the really critical areas of the application. And then once you've done that, once you've established that that works, you have 100% confidence you never use that part of the UI ever again. And that is basically the philosophy of Cypress. And it's what makes it a very different tool because architecturally it enables you to do stuff like that, right? So if you're going to log in, you need a user. Well, so just generate the state usually by, just making a request straight up to the database. And once you've done that, you have your user, you log in. Once you've established that, you don't ever use your UI to log in again. You have to understand your application. You have to understand where that session or where that state is stored. Maybe it's a local storage value. Maybe it's a cookie value. But you basically just create a boundary around every single like major UI feature. Once you've tested it once end to end, you never use your UI for that. And that's also kind of like why we're against the page object pattern, because the page object pattern encourages basically reusing the same UI actions across multiple unrelated pages and features. And, we just don't believe in that. That's where all these features get coupled together. And it's where you get the incredibly slow, brittle, flaky tests that are just repeating the same actions over and over and over again. And your confidence basically increases zero. And the tests just take way longer.
Cool.
Yeah, I agree with what Brian said. Good words.
What I love about testing is that there's always good debate and like different ways of looking at things, different reasons why people do it. I'm actually really looking forward to all of your talks. I'm looking forward to having a beer. There's going to be social event afterwards, so I think all of these conversations over beer are going to be very interesting. Speaking of tools, there's also a talk from the author of Detox, the React Native end-to-end sort of gray box testing framework. So there's going to be something there for mobile folks as well.
Yeah, I also want to remind everyone who's listening that all of these guys are going to be speaking at Assert.js, and I want to give that discount code that we promised at the beginning. Early bird tickets expire actually today, but you can still get 20% discount with the code HashBang. That's all caps HashBang, one word. And you can get them by going to the website, which is at Assert.js, which is all one word, .com. So anyone have any last comments before we finish up?
Because people who are listening to this are probably going to come to the conference, I think I can speak for all of us when I say, don't be afraid to come and talk with us after our talks or before our talks or anywhere at the conference. I personally love, like, one of the reasons I go to conferences is so I can meet people and talk with people and get to know what problems they're facing and just understand their the cool things that they're doing. So definitely feel free to come and chat with any of us.
Yeah, this is a small conference. It's going to be all about that. I'm looking forward to that.
That's great. Well, thanks everyone for the discussion. Definitely looking forward to seeing all of you in San Antonio. Thanks a lot, guys.
Awesome. Thanks, guys.
That's it for this episode of HashBang, brought to you by OKGrow, a JavaScript consulting and training company. Contact us at okgrow.com, okgrow.com.